All right, welcome to the video. This video is going to be scientific evidence, I should say undeniable, overwhelming, incredible, amazing, whatever word you want to use, evidence for the biblical Eve and the biblical Adam. And I am going to make sure that this is all under 30 minutes. And so here we go. We are going to get right into it. And the reason why I'm doing this and plan on doing more of this style is because, as people know who follow this channel, we put out a lot of content, and we put out a lot of content that is comprehensive. As in, we will do presentations, we'll give lectures, and oftentimes those videos will go between 2 and 3 hours. And so for those that are looking for a video comprising important information on the topic of ancestry, but they are looking for it to be under 30 minutes, around 20 minutes, then this is going to be for you. So let's have some fun. I want to start with some mottos. So here are a couple mottos, which I actually first heard from Dr. John Sanford, and I think they're excellent. And they are a really fantastic way to help convey or capture truth. And we'll start with the first motto. I want to make sure that the system looks good there. Okay, so the first motto is believe God more and believe man less. Remember, the Bible says that we are not to put our faith or our trust in the wisdom of man, but in the power of God. That is where our trust should go. And so believe God more and believe man less. And very important, good science always affirms scripture, which is absolutely true. The Bible claims to be the history book of the universe, and therefore we should be able to find that the account of origins in Genesis is reliable. The apostles took Genesis as literal history. Jesus Christ himself took Genesis as literal history. Jesus says from the beginning of creation, he made them male and female, referring back to the creation week and referring to Adam and Eve. And so the Bible is pretty clear that God created Adam and Eve independent. He created them special and separate from any other form of life on this planet. That includes chimpanzees, that includes dogs, and that includes fish. Eve, we are told, is the mother of all living. Adam is the first man. 2 Peter 3 says in the last days there's going to be scoffers. Scoffers who deny three things: the creation, the world that then was being overflowed with water, the Genesis flood, of course, and the coming judgment. And so let's see if the empirical scientific data that we know and have is consistent with the evolutionary model, which would reject a literal Adam and Eve who existed, who originated just thousands of years ago. And would the evolutionary model would argue that humans are related to every other form of life, including strawberries, including dogs, and of course, including your great ape. So let's go through several lines of evidence for the biblical Adam and Eve. So we'll start with mitochondrial Eve. I will be touching on Y chromosome Noah, genetic entropy, and also design diversity and DNA function. So mitochondrial Eve. Well, people, I'm sure, remember learning about mitochondrial DNA in school. And typically, mitochondrial DNA is referred to as the powerhouse of the cell. And people tend to describe mitochondrial DNA this way due to its fundamental or its key role in energy production. And because mitochondrial DNA doesn't actually change as rapidly or as quickly as your nuclear DNA. Remember, you have your nuclear DNA, and then you also have your mitochondrial DNA. You've also got your Y chromosome, which we'll talk about. That's inherited on the paternal side. That is also nuclear DNA. But mitochondrial DNA is important. It's a great way to answer this question of ancestry because it's not as messy as your autosomal DNA that basically recombines every single generation. You get the shuffling of DNA variants. And so it's less messy. It's not mixed with paternal DNA. And it leaves a much clearer record of distant ancestry. And so we know that mitochondrial DNA is, as I pointed out, uniparentally inherited, meaning it's only passed down on one side. It's passed down specifically from mother to child. And both sons and daughters, so I have mitochondrial DNA. If you're a man listening to this, you have mitochondrial DNA, but it is only daughters that pass on the mitochondrial DNA onto their child. And so essentially mitochondrial DNA worldwide is very low in variation. All mitochondrial DNA is nearly identical. As a matter of fact, diversity in general within humans is low. And I want to touch on this as kind of a subset of the overall mitochondrial Eve and Y chromosome Noah topic. And that has to do with levels of genetic diversity. And so the Bible claims that our starting point in terms of human origins was with two people, Adam and Eve. And so right off the bat, that would actually restrict levels of genetic diversity. Now, if we've been evolving for hundreds of thousands of years, right? The evolutionists would argue that we go back to Africa. That's where they put their Y chromosome Adam and their mitochondrial Eve is in Africa, a couple hundred, 100 to 200,000 years ago, roughly. And before that, you'd go back to Erectus, who apparently lived on this globe for about 1 million years. Before that, you'd go back to Homo habilis. Before that, you'd go back to Australopithecine-like ancestors. And so if we've been evolving for hundreds of thousands of years to millions of years back to Australopithecine-like ancestors, well, that would be a lot of genes floating around these populations, okay? And so we should expect humans to have high levels of genetic diversity, but this is not what we find. But this is what we should have discovered if human evolution and common descent were true. Now, what we do find is incredibly low levels of genetic diversity. All humans are nearly identical genomically. We are 99.999% the same. Mitochondrial DNA, nearly identical worldwide. Y chromosome DNA, nearly identical worldwide. And so this makes sense from the biblical creation starting point. We start with 2, roughly 6,000 years later, or if you want to start at the flood, 4,500 years later, we have humans who have low diversity. But another prediction or expectation would be the fact that God did not just create 2 of every kind of animal. He created animals in bulk. He created animals in populations, in fully working and functioning and healthy ecosystems. And so we would expect higher levels of genetic diversity in animals. And that's exactly what we find. Of course, there's an exception to the rule, but the exception does not overturn the rule. Humans overall have low levels of genetic diversity. Animals outside of humans have higher levels of genetic diversity. And that makes sense, especially at the flood bottleneck. It was a 1-generation bottleneck followed by rapid and exponential population growth. And so very little of that original created heterozygosity would have been lost. So most of it would have been retained and passed on to subsequent generations. Now, this is all inconsistent with the evolutionary model. They did not predict this. They did not expect this. And so what they did, rather than tap out and admit that this is a serious challenge to evolutionary theory to the point where it may indeed preclude evolutionary theory. And so they argued that this is post hoc ad hoc, right? Ad hoc because it's after the fact. And so they argued that there must have been some near extinction event. And some place this near extinction event 70,000 years ago, some place it hundreds of thousands of years ago, some place a near extinction event with Erectus. Some have, multiple out of Africas, basically with Erectus leaving, and then the Erectus that stayed in Africa evolved into Homo sapiens, and then eventually Homo sapiens left And so there was another out of Africa, but then that group met up with Neanderthals, met up with Denisovans, met up with, and that's where you get other groups like Naledi, Floresiensis, who is the Hobbit, Heidelbergensis. Anyways, so they argue that there is a near extinction event that basically drove the human population in Africa down to between 2 and 10,000. Some say maybe 30,000. But typically they'll say 2 to 10,000 because it needs to be low. And it also needs to be an extended bottleneck. It can't be a 1 generation or a 2 generation bottleneck. It has to be an extended bottleneck because that's the only way to explain how those levels of heterozygosity can shift to higher levels of homozygosity. So homozygosity, a state of no genetic, it goes back to basic genetics and alleles, right? Capital A, lowercase a, capital B, lowercase b. That would be genetic heterozygosity. If it was capital A, capital B, then that is genetically homozygous. There's no DNA diversity there. And so there needs to be a shift from more levels of DNA diversity to less levels of DNA diversity. So a shift from more heterozygosity to more homozygosity. And so this population needs to remain in a near extinction event for many generations, thousands of years. It's hard to get an exact number in the evolutionary literature, as a matter of fact, because it is just a story. There's no evidence for this. It's something that they required. Unfortunately for the evolutionist, they explain the origin of DNA diversity in general through mutations. Deleterious mutation accumulation is how they explain genetic diversity. It's how they explain nuclear DNA. The creationist has a very different explanation for the origin of autosomal DNA, especially. And that is created nuclear heterozygosity, where God would have front-loaded Adam and Eve and the original created kinds with pre-existing DNA diversity, which makes sense both theologically and scientifically, because when God said, be fruitful and multiply, he did not mean for that to be carried out through cloning. And so for Adam and Eve to have started genetically homozygous would make no sense. Anyways, we don't have to worry about an inbreeding problem right after creation, because Adam and Eve would have been created without mutations. Inbreeding becomes an issue because it reveals the hidden reservoir of genetic mistakes and mutations that have been passed on from generation to generation, that have accumulated. You have these recessive mutations. You got dominant alleles, recessive alleles, and so those recessive mutations, they're going to come to the forefront. They're going to lead to rapid and accelerated genetic degeneration. And that's exactly what would have happened in this so-called near extinction event in Africa. It's not feasible, because you would have had all these mutations popping up. This population would have been incredibly inbred. And we're supposed to believe that through this near extinction event, through all of this inbreeding and genetic degeneration and diseases popping up due to the inbreeding, that suddenly this population of 2 to 10,000 left Africa, spread out all over the globe, and seized dominion over the planet. No, that's a fairy tale. And so it's post hoc, ad hoc. The evolutionists can believe in it, but it's not science. It doesn't belong in a textbook. It's essentially a rescue device. And so the rescue device, it's not feasible. It's a story. But overall, the levels of genetic diversity fits perfectly from the biblical perspective and the biblical starting point, because again, we start with 2. Okay. So let's move on to Y chromosome Adam/Noah for now. And then as I go through all these, I'm going to move into a couple family trees that I want to touch on before we wrap things up. And remember, I'm keeping this all under 30 minutes. So Y chromosome Adam/Noah, we say Noah because for humans, our last Y chromosomal ancestor would have been 4,500 years ago off of the ark with Noah and his 3 sons, Shem, Ham, and Japheth. And so all Y chromosomes worldwide, all male Y chromosomes, they're nearly identical. There's extremely low variation. You can take every single male Y chromosome and you can build a family tree, and you'll see that they go back to one Y chromosomal ancestor in the not so distant past. The mutation rate in the Y chromosome is very fast. It's roughly 1 to 3 per generation, depending on whether or not you're looking at high quality sequencing data or low quality sequencing data. But even if you went with the 1 mutation per generation, it's still far too high for evolutionists to explain, because the variation is so low, the mutation rate is fast, and so there should be higher levels of genetic diversity. There should be more mutations. As a matter of fact, we should find mutation saturation. And so they have to invoke unrealistic amounts of natural selection, bottlenecks, near extinction events, all of these ad hoc. It's not a simple explanation. And oftentimes the more simple explanation is the truth. It's the true explanation. And so Y chromosome DNA variation points us right to the biblical model, because there's only 4,500 years worth of mutations. The only way to have a Y chromosome that has low variation, very few mutations, but it also mutates fast, is through young earth creation. It is young. And that is the most parsimonious explanation. If what the evolutionists are saying is true, then, especially in light of the faster mutation rate in the Y chromosome, we should find highly divergent populations around the globe in terms of the Y chromosomal mutations. Because once people spread out into all parts of the globe and they start breeding within their groups, you're going to have Y chromosomes around the globe that are isolated and accumulating their own diverse mutations, which means those Y chromosomes should be different than other Y chromosomes on the planet. But again, we see such uniformity, which makes sense because roughly 4,000 years ago, we have the Tower of Babel, and that's when people groups spread out into all parts of the globe. And from there, you get mutations accumulating in independent people groups as people moved out. But yet we still have such uniformity, which means the spreading out only happened thousands of years ago rather than hundreds of thousands of years ago. And so this is a major problem for the evolutionists. Not only that, when we bring in the chimpanzee Y chromosome, the evolutionary community, they were shocked, surprised. It's unexpected. The Y chromosome in chimpanzees, when you consider overall gene content, overall architecture, and overall size differences, it's only about 35 to 40% the same. And so it's nothing like the human Y chromosome. And yet we're supposed to believe that chimpanzees are our closest cousin on the tree of life. It actually turns out that the human Y chromosome and the gorilla Y chromosome are more similar to each other than either are to the chimpanzee Y chromosome. And so that is an inconsistency. That is a break in the nested hierarchy that evolutionists love to hold up and praise as amazing evidence for universal common ancestry. There's also something called orphan genes, these taxonomically restricted and essential genes, and there's no consistent hierarchy with orphan genes either. And so, yes, there's a general nested hierarchy in the biological world, as the design hypothesis would expect, but there's also a lot of inconsistencies. Convergent evolution, that is another major inconsistency for the evolutionary model. And anytime convergent evolution is invoked, it is an admittance into the lack of uniqueness of the universal phylogenetic tree. And so, to recap, in terms of the Y chromosome, every single male Y chromosome is nearly identical. We have a fast mutation rate, low variation. Bring in the chimpanzee, as expected from the biblical creation model, because we hold a separate ancestry. The Y chromosome is nothing alike. It's half the size. Much of its gene content is totally different. Much of it is missing. And so the evolutionary community have to invoke some really unrealistic changes. They've never presented a mathematical model to explain this data. I've been challenging them for at least 2 to 3 years. And the arguments that they do invoke, like sperm competition or faster rates of gene conversion, they've never been tested. And the evolutionary community, they actually admit that these are untested hypotheses. Okay, so let's move on to genetic entropy. Genetic entropy is essentially the concept that, as most mutations are deleterious, they're also nearly neutral. And so they accumulate unchecked. Selection can't see them. And so they build up over time. and biological organisms increase in terms of their deleterious genetic load. And so we understand that these mutations, since they spread, they're subject to genetic drift, and so they spread through the population, and they result in genetic sickness. Natural selection can't save the day, because the question for the evolutionist is, what kind of selection can you invoke to remove so many deleterious mutations that are pouring in to the genomes of biological organisms generation after generation, in light of the fact that these mutations are nearly neutral? Nearly because they're slightly deleterious, much like a single spelling mistake in a book the size of an encyclopedia. On its own, it's inconsequential. But as these spelling mistakes build up over time, as they accumulate over time, they ruin the message of the book. And so it takes time for them to accumulate, but the damage is continuous, it's relentless. It's much like rust on a car. A single rust molecule on a car is inconsequential on its own. But as these rust molecules build up over time, let's say you have a car and it's 10 years old and there's just all these rust marks, the degeneration of that vehicle, that automobile, is inevitable. And that's what we see going on in genomes. The human mutation rate is roughly 100 new mutations per person per generation. That's incredibly high. And that's in the autosomal DNA. In the Y chromosome, it's 1 to 3 per generation. In the mitochondrial DNA, it's about 0.5 per generation. And so it's fast no matter where you look. There's low variation, but again, the mutation rate is high. We understand that there's evidence for genome-wide activity and function. And that means these mutations are even more deleterious as they accumulate. Even serious population geneticists have admitted, they've conceded that in no way can a mutation be truly neutral, strictly neutral. They all must have some effect on fitness, even if that effect is vanishingly small. They also admit that the vast majority of mutations are deleterious. But again, because they're nearly neutral, they accumulate, they go unchecked, they spread to the population. And so what we actually see in terms of the so-called driving mechanisms of evolution, natural selection, which is limited, it can't remove these deleterious mutations from the equation. It's also only a fine-tuning mechanism, keeping a species as strong as it can be, and mutations are degrading. Even your best beneficial mutations, when you look under the hood, because what I find with the evolutionary community is beneficial mutations, they're almost exclusively identified and categorized by their phenotype rather than by their genotype. We should be looking under the hood. We should be looking at what's going on the genotype, which is basically the genetic systems. The phenotype is the physical characteristics of the organism, okay? And so when we look at the genotype, we notice that these beneficial mutations, they turn out to be reductive. They're degrading, they're functionally compromising to the organism. We see the breakdown of pre-existing systems. And so beneficial mutations aren't going to save the day. They're too rare. They're about 1 in a million, the Lenski experiment discovered. And when they do happen, they are typically reductive and functionally compromising to the organism. And so even if, for sake of argument, you wanted to give the evolutionists 100 truly beneficial mutations with no deleterious effects on genotype, it's still not going to save the day. It's still not going to counterbalance the damage due to the influx of so many low impact, nearly neutral and deleterious mutations that are pouring in generation after generation. Let's say we had a room full of people. Okay, let's say we had a room with 100 people. Every single person has accumulated mutations from the previous generation. And so every single person in that room is essentially mutant. Let's invoke unrealistic, strong selection. Let's say selection were to be able to remove 50% of the worst mutants in that room. And so we're left with 50 people, and those 50 people are not as mutant as the other 50 people that are no longer in the equation. Well, guess what? Those 50 people have still accumulated mutations from previous generations. And so they're still multiply mutant. And so even with intense selection, all you're ever going to do is slow down the damage. but the damage itself is inevitable, and there is no solution to the mutation accumulation problem. Okay, design diversity and DNA function. Again, the creation model starts off with organisms being front-loaded with DNA diversity and with high levels of heterozygosity. We would also argue my specific model, as I've written a book on endogenous retroviruses, I would argue that God would also front load genomes with functional DNA units that are necessary to sustain healthy life processes in the cell in many ways. For example, endogenous retroviruses, we understand that they act as antiviral protectors. We also know that they perform viral mimicry and act in tumor suppression. They help to determine cell types. They help in gene expression. They help in embryological development. They help in the placenta. And so they're incredibly important. Pseudogenes, we understand that a lot of these pseudogenes have documented functions. They're necessary, again, to sustain healthy cell processes. And there's so much involved in pseudogenes that I just don't have enough time to discuss right now. We understand there's evidence for roughly 80% of the genome being active. The evolutionists want to argue, well, this activity is just spurious. It's just noise. If this was really just spurious and really just noise, then why is it still around? Why hasn't selection, which apparently with mutations has taken a single-celled like ancestor into a whale over time, why hasn't natural selection removed all of this genetic baggage and all of these evolutionary leftovers from the equation? It's wasteful of energy. It's wasteful of resources. Every time you add a single nucleotide to a growing RNA chain, you are consuming energy. You are consuming energy. You're using ATP. And so this is an energy-intensive process, transcription that is. DNA to RNA to protein. DNA transcribes and RNA translates into protein, but your non-coding regions of the genome, we find a lot of function in regulation. These long non-coding RNA genes, for example, function in a variety of ways. They're critical to the health of the cell. And also, if these RNA transcripts being produced were just being produced because the genome's messy, well, that would just clutter up. That would gum up systems and operations within the cell. And there's just so many reasons why this evidence for genome-wide activity is clearly not just noise. It's not just spurious. It is legit. It is in the cell, and it's there for a reason. Okay, we understand that the genome is four-dimensional. There are multiple overlapping codes within the genome. Okay, we write books that can be read forwards, but we don't write books that can be read both forwards and backwards. And every other letter, you have a third message. The genome is nested and it's full of meta information and data. And this is exactly what we would expect if the design diversity starting point were true. Okay, in my last few minutes here, I want to go over these family trees. And so we have the mitochondrial DNA family tree here. This was derived by Dr. Robert Carter. And basically, this is worldwide mitochondrial DNA. I pointed out earlier that this little piece of DNA, this mitochondria, the powerhouse of the cell, we get this piece of DNA strictly from our mother. And it's passed down intact from generation to generation, which is why we call it uniparentally inherited DNA. Okay, so as mutations accumulate from generation to generation and the DNA compartment changes, more and more branches are added to this family tree. And you'll notice the fact that firstly, there's low genetic variation. We see a classic starburst pattern. See, the thing that the evolutionary community don't want to address is the fact that we have low variation. We have evidence for one woman. Okay. They want to argue against the starburst pattern, right? You see this explosion from the middle, from a center point, just as we'd expect if biblical creation were true, because we have Adam and Eve followed by rapid and exponential population growth. Then you have a crash at the flood. And then again, from those three reproducing couples, you have rapid and exponential population growth. And that's what you would expect, is these branches spreading out. in a starburst-like manner. Nonetheless, what the evolutionists fail to address and engage is the fact that overall, we only have a few mutations. On average, we have between 20 and 25 mutations between any two people in the mitochondrial DNA. That's nothing. That is easy to account for. This is biblical time. We mutate too quickly and there exists very low genetic variation. That means Eve existed in the not so distant past. We also realize that mutation rates are variable. They're not constant. Notice this haplogroup here, the HVR haplogroup in Europe. Notice the differing size branches. That means some people are picking up more mutations in the same amount of time than their cousins. And so, no, you can't assume a strict constant molecular clock as many evolutionists do. And so the problem for the evolutionists is when you look at a phylogenetic tree like this of mitochondrial DNA worldwide, is you don't find thousands of generations. You only find a couple hundred generations, and that is it. The same thing is true with the Y chromosome. And so this is a family tree of Y chromosomes around the world. And notice they too go back to a central point. And you don't need a phylogenetic tree to figure that out. Again, every single human male Y chromosome is nearly identical, and they go right back to one Y chromosomal ancestor in the not so distant past. Again, the mutation rate in this DNA compartment, it's incredibly fast. The variation is low. There's not thousands of generations in this Y chromosomal family tree. There's only a couple hundred generations worth of mutations on this family tree, which tells us that humanity has only existed for several thousands of years rather than hundreds of thousands of years into Africa. Genetics provides some of the most amazing evidence for separate ancestry, and that is just over 30 minutes. I got it done in about 32 minutes, and so I feel like I did all that in one breath. Okay, so we got to talk about mitochondrial Eve, Y chromosome Noah. We got to talk about levels of genetic diversity and how they point to an Adam and Eve scenario and not an evolutionary scenario. We got to talk about design diversity and DNA function, and it's a great time to be a biblical creationist, guys. That's the last thing I want to say. I think that's a good place to end it. Remember, good science always affirms Scripture. God bless.